Mrs. Meyer passed out to you guys this flow chart. Uh, Keep this. Okay, don't lose this flow chart, guys. This is just the start of it. Okay, as we go along here during the school year, we're going to be adding to this flow chart. Okay, so don't lose this flow chart. We'll, like I said, when we do add to it, we'll print you out some new charts. Okay, but in the meantime, this is the start of factoring. Now we started factoring before the quiz, right? Last week, and we did the common factors. Okay, that was on the quiz where we had to determine, um, if there were any common factors in the terms. We did binomials. We haven't done trinomials with common factors, but remember, we looked at the numbers. We would take out. Let's see. We looked at the 8 and the 12. We took out the 4. 8x divided by 4 is 2x, and 12 divided by 4 is 3. So we did some simple common factors that we undistribute, right? We called it undistributing. Then we looked at the next step, trinomials that had coefficients of 1 for the x squared. Okay? In other words, you don't really see those coefficients of 1 because we normally don't put them in there. So we say no coefficients of the x squared, but there really is a 1 there. Don't forget where the standard form of a quadratic expression or equation is, in this case, y equals ax squared plus bx plus c. And you might as well get used to this because I refer to this an awful lot. In fact, we'll be talking about the coefficients a, b, and c. Okay. And c we usually call a constant. B is a coefficient of x to the first. A is a coefficient of x to the second, x squared. Okay. All right, so we did problems, trinomials, where we factored with the a equaling 1. The coefficient of x squared equals 1. Okay. Those were pretty simple. The only way to get x squared is x times x. Remember, we're doing FOIL backwards or undistributing kind of. And then we would took a look at that for the C, and we would come up with factors for C, like 1 times 4, 2 times 2. It had to be multiplied to get a positive number. So it either had to be positive times a positive or negative times a negative. To determine that, we looked at the sign for the B, which is positive. So they had to add up to a positive. So we for this example, we would use positive times positive, positive times positive. Then that told us that we're going to add these together. Sometimes they subtract, like for a negative, but this time they're going to add up to 5. So the only factors that are going to add up to 5, well, 2 plus 2 isn't 5, but 1 plus 4 is 5. Those are our factors, 1 and 4. And this then is my factored form for this trinomial. X plus 1, and then x plus 4. And then we use the arches, right, to check. See, my inner is 1x, my outer is 4x, positive 1x plus positive 4x gives me my positive 5x, which matches my middle term. So I know for sure that my answer's right. So that's where we left off for factoring. Kind of a little review. Now we're going to talk about when my a does not equal 1. My A is going to be greater than 1. Okay, this is where things start getting a little bit more difficult, especially when my coefficient A here, it happens to be 2. This 2 is a prime number. They get more difficult when that A is not a prime number. For instance, number 9, 8 is not a prime number. And what I mean by prime number is the only way you can get 2 is to take 2 times 1. 8, I got 8 times 1, 2 times 4, so there's different factors to use. If it's 8, if my A is a prime number, it still is not too bad of a problem to factor. Okay? Because there's only one way to get 2, and that's 2 times 1, right? And the only way to get x squared is x times x. So I still can easily get my first term factored out. 2x times 1x is 2x squared. Now I'm going to look at my c. Now that I got my uh, squared term, I'm going to look at my c, which is positive 3. So the only way I can get positive 3, 1 times 3, right? Okay. It's a positive 3, so either I'm going to do multiply a positive times a positive or a negative times a negative. To determine what sign I'm going to use, I'm going to look at the sign of that b term, which is positive. So I know that I'm going to use positive times a positive because they got to add up to a positive. Now, here's the problem. Well, not a problem, but this is where we have to figure out, do I put the 1 here and the 3 there, or the 3 there and the 1 there? And don't forget, we're going to be multiplying the inner and the outer. Okay, they're going to have to add up to that 7x. So let's look at the first way we can do this. Let's put the 1 here and the 3 in this one. Okay, let's check it. The inner 1 times 1x is positive 1x. The outer 2x times 3 is a positive 6x. Add those together, I get my positive 7x. That's what I want. So I know that this is the factored form. So things are getting a little more difficult, right? So my answer here, 2x plus 1 times the quantity, 1x plus 3. This is going to take practice. This is not, for 99% of you, this is going to take some time to get used to, right? It is. It's not like it's going to come like this. Yes, he. Okay. Are you going to be here after school? Yes, I will be here after school today. Oh, and there are late buses tomorrow. We got an email about late buses. So I will be here after school tomorrow. If you want to stay, there's late buses for that too. Okay, number 8. All right, my A is still a prime number, so I'm okay. I'm going to go ahead and put my 3x in there and my 1x. I'm going to leave the 1 out. So 3x times 1x is 3x squared. Then I'm going to look at the factors of my c. So I have 10. The factors of c, let's see, 1 times 10, 2 times 5, right? It's a positive, so it's either going to be a positive times a positive or a negative times a negative. I'm going to look at the sign of my b term, and it's a negative, so I'm going to have to use negative times negative. Negative times negative. All right. Now I have to try either 1 times 10, maybe 10 times 1, 2 times 5, or maybe 5 times 2. So now they're getting even a little harder here. Now, most of the problems, I'm not going to say all, but most of the problems that you're going to run into are going to be like the middle factors. But don't, I mean, it's just that's what I see with a lot of the problem. Not that they can't be the 1 times 10, but I'm going to start out with a 2 times 5. Okay? So I'm going to put a 2 and a 5 in there. More than likely, the problem's going to be those factors that are closer together. I'm going to put a 5 here and a 2 here just because I know what the answer is and I want to show you. Going to check my inner, going to check my outer, and see if they add up to negative 17x. Negative 5 times x is negative 5x. 3x times negative 2 is negative 6x. They add up to negative 11x. And I need negative 17. So the 5 and a 2 is not going to work. And this is where pencil and mathematics comes in really handy. But I'm not going to go right to the 1 and 10 yet. I'm going to put the 2 here and the 5 here and check that. So the inner, negative 2 times x, is my negative 2x. The outer, 3x times negative 5 is negative 5x. Add those together, I get my negative 17x. There's my answer. Huh?
Negative 15.
Yeah, negative 15, sorry. So that's my answer. It's 3x minus 2 times the quantity x minus 5. Okay, questions? Now we're going to get a little more difficult because my a is no longer a prime number. Yeah. 8 has different factors. 8 has 1 times 8 and 2 times 4. Okay. My 9 has 1 times 9 and 3 times 3. Okay. I'm still going to need my factor symbolization. 1 times 8 is 8, and 2 times 4 is 8. These are my factors of 8. I'm looking. These are the factors for my A is 8 here. Okay, so I need the factors for 8. This is my C, so I need the factors of my C 9. 1 times 9 is 9. 3 times 3 is 9. Okay. So I don't know if I'm going to use the 1x and the 8x or the 2x and the 4x or the 1 let's see plus 9 plus 1. So I'm just going to have to guess and try. Again, not it's pretty seldom that problems are going to use the 1 times it's the number. And again, I'm not saying that they don't. It's they're more than likely to use factors that are closer together. So I'm going to try the 2 and the 4. Actually, I'm going to put the 4 first. So this is for my 8x squared. I'm going to try 4x times 2x to get my 8x squared. Then I'm going to try the 3 times 3. 3 times 3. Now, it's a negative, right? My c is negative. So one has to be positive and one has to be negative. Now, it might be the other way around too. This might be the negative, this might be the positive. So not only do we have all these choices for the factors of 8 and 9, we have to try the signs. So this is actually a tough problem. All right, let's get our arches in here and start seeing what our guesses are like. Okay, positive 3 times 2x is a positive 6x. And believe it or not, I picked the right numbers right off the bat. So I got a 4x times negative 3, negative 12x. Add those together. Positive 6x minus 12x is a minus 6x. And lo and behold, that's exactly what I want.
Is it all right if we have it the other way where 2x minus 3 is first?
Yep. Remember, these are numbers, right? Okay. The quantities represent a number or value. So it's multiplication, right, between them. Multiplication is commutative. You can change order. That is the same as 2x minus 3 times 4x plus 3. Good question. So those are my factors. 4x plus 3, 2x minus 3, and I got it on the first try. I got extremely lucky. Not an easy thing to do when our A is not a prime number. Now imagine if this was like 12 and this was like 24. Then you would have a couple of more choices. It gets really hard. All right, the next thing I want to talk about is what's called difference of squares, number 10. And if you look at number 10 here, it's x squared minus 36. Now, what do I mean by perfect squares? And it's on your little flow chart there that you got. Well, that means 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared equals 25, 6 squared equals 36, so on and so forth. Okay? Yeah, it's a number by times itself. That's what squared is. These are called the perfect squares. So if I'm looking at, we have a special formula to factor these out. And if you can remember this, it's going to save you an awful lot of work. In fact, you'll have your flow charts. It's on your flow charts. So even on quizzes, we let you use the flow charts. So remember, don't lose those. Okay. So I look at this and I notice that 36 is a perfect square. So I'm going to rewrite this as x squared minus 6 squared. Okay. Now, if you turn to the next page, we have a little formula for factoring perfect squares. A squared minus b squared is a plus b times quantity a minus b. Now, in our previous problem, remember I changed it to x squared minus 6 squared. See how they are exactly in that form? Now, what we do is for the a and the b here, for the general equation, we use the bases. So my a is the base x, My b is going to be the base 6. So when I go to put it in the formula, my a is x plus b, my b is 6, times my a is x minus my b, which is 6. So it's a shortcut. They come up a lot, actually, in algebra. Okay, let's look at number 11. I'm going to rewrite this as x squared minus 3 squared. My a is going to be the base x. My b is going to be the base 3. So my factors is going to be x plus 3, x minus 3. Number 12, I'm going to rewrite this as 2 squared x squared, because 4 is a perfect square of 2, minus my 81 is a perfect square of 9. So here my a is going to be the base 2x. My b is going to be the base 9. So when I go to put it in my factored form, it's going to be a 2x plus b, which is 9, and my a 2x minus my b, which is 9. Yeah, this is a lot. This is a lot a lot of work. That's why we're going to be spending 3 days total on this. Okay, I'm going to skip perfect square trinomials for now. Um, doesn't mean I'm not going to hit them up later. Okay, I'm just going to skip them for now. All right, now we got to throw in some regular problems that uh, we're going to try to follow this flow chart for. Okay, if I'm looking at number 15, let's try using our flow charts. So the first thing I'm going to look for, can I factor out any common terms? Are there any common terms in 5x squared plus 20x plus 15? 8.
Yes.
What is it?
5.
Yeah, I can take out a 5, right? So 5x squared divided by 5 is x squared. 20x divided by 5 is 4x. And 15 divided by 5 is 3. Now I have a relatively easy trinomial here to solve to factor because my a is 1, right? So I have my 5. Don't forget to bring down the 5. Going to factor the rest of it. So I have an x and it times x gives me x squared. This is a positive, and they add up to a positive. So this is a positive and this is a positive. And I only have 3 is a prime number. The only way I can get 3, 1 times 3. And since a is a 1, I don't have to really worry about whether I put the 3 there or the 1 there and whatnot. If you really want to check it, this one you almost don't need to check because we dealt with all prime numbers. 1x, positive 1x, positive 3x gives me positive 4x, which is what I want. And the last one, 16. Again, follow our flow chart, factor out any common terms. Can I factor out any terms here? Common terms. Look at the numbers 2 and 32. They're both even, so I know I can take out a 2. 2x squared divided by 2. 32 divided by 2. 16. Now look at 16. Now you're hopefully, yeah, your chart's going to be bigger. So if you look at your perfect squares, 16 is a perfect square, right? It's 2 times x squared minus 4 squared. So my a equals the base x. My b equals the base 4. So when I go to factor this, I have my a, which is x plus b, which is 4, and x minus 4. Now, don't expect to be factoring masters after doing half dozen problems. It's going to take some practice. So we're going to have worksheets and Delta Math practice for this. So it's going to just take a lot of practice to get this down. Are there any questions?